Today we're going to be finding percent. And we'll find percent by simply calculating what the part is with relationship to the whole. Let's take a look at an example. Let's say a basketball player makes 1 out of 2 shots. Now if we look at that as a fraction, we have 1 out of 2, the 1 being the part that they made and the 2 being the whole. Some students might be able to identify that immediately as 50%. So let's take a look at a problem that's a little bit more challenging. Let's say the basketball player makes 7 out of 8. Now, we have 7, that's the part that they made out of the total shots that they took, that's 8. So we can also maybe identify this almost immediately as 87.5%. So we need to be able to identify how we get that calculation. Now, here comes the trick. So the trick here could either be a rule or a pattern, depending on how you feel. I really don't care that much. But we have a part that's divided by the whole times 100. That'll always give you the percent. And the part is the numerator, divided by the whole, which is the denominator, times 100. Now, let's take a look at a painting by Ellsworth Kelly. And he painted it back in 1951. Let's get a little history on this.
He bought huge supplies of the colored adhesive paper that you could buy in art supply stores in Paris. He made these collages, randomly distributing the 18 colors according to mathematical systems that he devised for each one. And then when all of those collages were finished, he had some leftover squares.
He decided to make a couple of small collages with those leftover squares, including the collage that we see on the wall that's just 8 squares across and 8 squares down. As you can see, there's a lot of white, because Kelly didn't have all that many colored squares left.
He said it perplexed him, and in the end, he decided he was going to make a painting and made colors for a large wall. And what you have is a very radical painting for 1951. The approach that Kelly took in this painting of letting color fall where it may was something that was very liberating for him, and that an artist could work with color with a freedom and almost with a nonchalance and still end up with something beautiful.
Now, how many times do we think that some students might recognize math as perplexing or radical? There also might be some who recognize it with a sense of freedom, nonchalance, and beautiful. If we take a look at this particular painting, there's a lot that we can do with respect to math. Now, I'd like to take a look at finding percent. Now, with respect to the red colors, I can identify based on the part, which are the red squares that are there, and identify and calculate what percentage of those total squares are red. Now, we can identify these 2 squares as red. So the part is 2, divided by the whole, or the total number of squares, which is 8 by 8, which is 64. And if we simply multiply that calculation times 100, we get our percent, which is 3.1, rounding to the nearest tenth. Now let's take a look at another color. If we take a look at the black squares, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 black squares. So the part that we have here are 12, the 12 black squares. Divided by the whole still stays the same. There's still 64 squares. So 12 divided by 64 times 100, that's our rule, and that equals 18.8%. Again, rounding to the nearest tenth. Now, you can continue on calculating all of the different colors in this particular painting and get a total of 100%. But in addition to that, you can also, with other cross-curriculum ideas for art and math, you can work on area, you can work on perimeter, you can do length conversion. You can also make this as a end-of-the-year project and make a big, giant mural for the school. The ideas are endless. Thank you.